A non-living part of the environment, like water, light, or temperature. Abiotic factor. Abiotic factors are the non-living elements of an ecosystem that affect living organisms. Have you ever tried to bake a cake, but realized halfway through that you're missing a key ingredient like eggs or flour? Just like the success of a cake depends on having all the right ingredients, the survival and prosperity of an ecosystem depend on abiotic factors such as water, light, and temperature. Without these non living components, similar to missing ingredients in a recipe, an ecosystem cannot function properly, as they provide the necessary conditions that support life and allow living organisms to thrive. A living factor in the environment, like plants or animals. Biotic factor. In simple terms, a biotic factor is any living part of an ecosystem that can affect other organisms. Imagine you're trying to set up a successful dinner party, but you're struggling to decide who to invite for the best atmosphere. Just like the right mix of guests can make or break the party mood, biotic factors like plants and animals play a crucial role in shaping an environment. In this analogy, the guests represent the biotic factors, where each person or living factor contributes to the dynamics and success of the environment, just as plants and animals do in an ecosystem. Populations that live in the same habitat. Community. In science, a community is a group of different species living together and interacting in the same area. Imagine trying to coordinate a big neighborhood block party where every family brings a different dish. Just like each family at the party contributes something unique to the event, different species within a habitat contribute various roles and resources to the ecosystem. Each family is like a different species, and their dishes represent the diverse roles and contributions they make to the community, ensuring the party or ecosystem is vibrant and functional. All the living and non living things interacting in an area. Ecosystem. An ecosystem is like a community where plants, animals, and non living things like water and rocks all work together. Imagine trying to organize a chaotic family gathering where each member has different needs and preferences. This is similar to how an ecosystem functions, with various living organisms and non living elements interacting in a specific area. Just as you might balance Aunt Mary's preference for quiet with the kids' need for play space, an ecosystem balances the needs of plants, animals, water, and sunlight to maintain harmony. All the organisms of the same species living in the same area. Population. In science, a population is a group of the same species living together in one place. Imagine trying to manage a group chat where all your friends are discussing where to meet up for dinner. Just like how you need to coordinate with everyone in the chat to ensure everyone ends up at the same restaurant, a population consists of all the organisms of the same species living in the same area, interacting and functioning together. In this analogy, each friend in the group chat represents an individual organism. The group chat itself is the specific area they all inhabit, and their goal of meeting for dinner mirrors how populations interact and thrive within their ecosystem. The first species to populate an area, pioneer species. Pioneer species are the initial organisms that begin colonizing barren environments, paving the way for other species to establish. Imagine moving into a new neighborhood where no one has lived before and having to establish the first home. Just like you, pioneer species are the first organisms to move into a barren area and begin the process of creating a living environment. In both situations, whether you're setting up a house or pioneer species are colonizing new land, the initial presence creates a foundation that makes it easier for others to follow, akin to how your presence might encourage more families to settle in the neighborhood, paving the way for a thriving community. Large areas with similar climates, plants, and animals, like a tundra, taiga, or desert. Biome. A biome is a region on Earth with distinct climate, plants, and animals. Imagine trying to dress appropriately for the weather every day, whether it's a sunny beach day or a snowy winter morning. Just like your wardrobe changes based on the weather, a biome is a large area where the climate dictates the types of plants and animals that live there, such as in a tundra, taiga, or desert. Just as you wouldn't wear a swimsuit in a blizzard, plants and animals in a biome have adaptations that suit the specific climate and conditions, ensuring they thrive, much like your choice of clothes helps you stay comfortable. The place where an organism lives. Habitat. A habitat is the natural home where plants and animals live and find everything they need to survive. Imagine trying to find the perfect apartment that suits all your needs and preferences in a bustling city. Just like how you need a place that fits your lifestyle, budget, and daily routines, an organism needs a habitat that provides the right conditions for its survival, growth, and reproduction. In this analogy, the apartment represents the habitat. Your needs and preferences are akin to the organism's survival requirements, and the city is the broader environment where both you and the organism must navigate to find that perfect spot. An animal that only eats other animals. Carnivore. A carnivore is an animal that predominantly consumes the flesh of other animals for its diet. Imagine you're at a party and all the delicious party snacks are only desserts, but you really crave savory food. This situation is similar to a carnivore's diet because just as you are seeking something specific that isn't present, a carnivore specifically hunts for other animals to eat, ignoring plant-based options. In this analogy, your craving for savory food represents the carnivore's need for meat, and the absence of savory snacks at the party mirrors how carnivores bypass plants in favor of animal prey to fulfill their dietary needs. Unlike a plant, cannot make its own food. Instead, it eats other living things. Consumer. In science, a consumer is an organism that obtains energy by eating other organisms. Imagine you're trying to fix a broken appliance at home, but you lack the necessary tools. This situation is similar to the way some consumers in nature, such as animals, cannot produce their own food and must rely on eating other living organisms to obtain energy. Just as you need to borrow or buy tools to complete the repair, these consumers must borrow or acquire energy by consuming other plants or animals. In both scenarios, there is a dependency on external resources to fulfill a need. You need tools to fix your appliance, and consumers need other living things to obtain their energy. An organism that breaks down dead organisms and waste, like fungi or bacteria. Decomposers are organisms that recycle nutrients by breaking down dead material. Imagine you're cleaning out your refrigerator and you find leftovers that have gone bad. Just like you break down and dispose of these spoiled foods to make space for fresh groceries, decomposers like fungi and bacteria break down dead organisms and waste in nature. In both scenarios, the process of breaking down and clearing out the old to make room for the new is essential. You are the decomposer of your fridge, while fungi and bacteria do the same for the ecosystem, ensuring it remains clean and balanced. Organic matter or animal waste that can be burned for energy. Biomass. Biomass is material from plants and animals that can be used as a renewable energy source. Imagine trying to figure out how much food is in your fridge without opening it. Just as you estimate the total amount of groceries by considering the weight and volume of each food item you've put in there over time, biomass measures the total mass of all living matter in a specific area. In this analogy, each food item represents an individual organism, and your fridge is the given area. Together, they combine to give you an overall sense of fullness or total mass. just like biomass does in an ecosystem. An animal that eats only plants. Herbivore. Herbivores are animals that get their energy and nutrients by consuming plants. Imagine trying to pick a meal at a restaurant where you only eat vegetarian dishes. This is similar to the dietary choices of a herbivore, an animal that eats only plants. Just as you navigate the menu to find plant-based options that fit your diet, a herbivore navigates its environment to find suitable plant foods. Both are selective processes focused on plant-based nourishment. Can eat both plants and animals. Omnivore. An omnivore is an animal that consumes both plants and animal matter as part of its diet. Imagine you're deciding what to have for dinner, and you're torn between ordering a vegetable stir fry or a juicy steak. This dilemma is similar to how an omnivore operates, as it has the flexibility to choose between eating plants or animals, much like your choice between vegetarian or meat options. Just as you can enjoy both a salad and a steak in a single meal, an omnivore's diet includes both plant-based and animal-based foods, allowing it to thrive in a variety of environments and situations. The process by which plants use sunlight, carbon dioxide, and water to make food. Photosynthesis. In photosynthesis, plants take sunlight and turn it into energy to grow. Imagine you're trying to cook dinner, but you only have raw ingredients and no recipe. Just like how you need to gather and transform these ingredients into a meal using a recipe, plants gather sunlight, carbon dioxide, and water to create their own food through photosynthesis. In this analogy, the raw ingredients are like the sunlight, carbon dioxide, and water, while the recipe that guides the transformation into a delicious meal is akin to the process of photosynthesis itself. Organism that can make its own food, like all plants. Producer. A producer is a living thing that makes its own food through processes like photosynthesis. Imagine you're running late for work and realize you forgot your lunch at home. This situation is similar to how producers in nature, like plants, never have to worry about such a problem because they make their own food. Just as you might wish you could whip up a meal from thin air to avoid being hungry, plants use sunlight to produce their own sustenance through photosynthesis, ensuring they're always fed no matter where they are. An organism that feeds on animals that are already dead. Scavenger. Scavengers are animals that eat dead organisms that they did not hunt or kill themselves. Imagine you're at a party, and by the time you arrive, most of the food has already been eaten by the guests who came earlier. In this scenario, you find yourself scavenging through what's left on the buffet table, picking at whatever leftovers you can find to satisfy your hunger. This is similar to how scavengers in nature operate, as they feed on animals that are already dead, rather than hunting for fresh prey. Just as you rely on what's left at the party to fill your stomach, scavengers depend on the remains of deceased animals to sustain themselves, making efficient use of available resources rather than seeking out fresh ones. The food energy transfer between organisms in an ecosystem. Food chain. A food chain is a sequence that shows how each living thing gets its energy by eating another organism in an ecosystem. Have you ever played the game of passing a message down a line of people, only to find that the message changes slightly with each person? This is similar to how energy is transferred through a food chain in an ecosystem, where energy starts with the sun and is passed from one organism to another, changing form along the way. Just as the original message gets altered as it moves from person to person, the energy from the sun gets transformed from sunlight to plant matter to herbivore muscle and so on, illustrating how energy changes form as it moves through the food chain. a model of overlapping food chains in an ecosystem. Food web. A food web is a network of interconnected food chains showing how different organisms feed on each other in an ecosystem. Imagine trying to manage a group chat where everyone is talking to each other at once, sharing information, and making plans. This chaotic yet interconnected conversation is similar to a food web in an ecosystem, where various plants and animals interact in a complex network of feeding relationships. Just as each person in the group chat contributes to the overall flow of conversation, each species in a food web plays a role in the ecosystem, with their interactions overlapping and influencing one another, much like messages bouncing between group members to create a dynamic and interconnected dialogue. The largest population that an environment can support. Carrying capacity. Carrying capacity is the maximum number of individuals an environment's resources can sustainably support without degrading. Imagine you're hosting a dinner party and have a limited number of chairs and plates. Just like how you can only invite as many guests as you have seating and tableware for, an environment can only support as many individuals as its resources will allow. In this analogy, the chairs and plates represent the resources in an environment, such as food, water, and shelter, while the guests are the population. Once you've reached the maximum number of guests that your setup can comfortably accommodate, you've hit your carrying capacity. The diagram of energy loss through a food chain. Energy pyramid. An energy pyramid is a graphical representation that shows how energy decreases as it flows through different levels of a food chain. Imagine you're trying to keep a series of candles lit in a windy room. Each candle represents a step in the process of energy transfer, where the wind is like the inefficiency in energy transfer within a food chain. Just as you lose some flame to the wind with each candle you try to light, energy is lost at each trophic level in the energy pyramid, from producers to consumers. The wind symbolizes the natural inefficiencies where only a portion of the energy is passed on at each level, much like how only a fraction of the flame reaches each subsequent candle, highlighting the diminishing energy available as you move up the food chain. An animal hunted and eaten by a predator. Prey. In science, prey is an organism that is targeted and consumed by another organism known as the predator for food. Imagine you are at a busy buffet, trying to grab your favorite dish before it's all gone. Just like how you navigate the crowd and reach for the plate quickly before someone else snatches it, prey animals constantly have to be on the move, aware of predators ready to catch them. In both scenarios, there's a pursuit. In the buffet, it's your quest for food before others grab it, while in the wild, it's a predator's pursuit of prey, each striving to succeed in their environment. An animal that hunts and eats other animals. Predator. In science, a predator is an animal that captures and feeds on other animals. Imagine you're trying to find a parking spot in a crowded shopping mall during the holiday season. Just like a predator scanning its environment for prey, you navigate the lanes, searching for an elusive open space to claim. In this scenario, you're the predator. The parking spots are your prey, and the crowded parking lot is your hunting ground, where success depends on your ability to spot and seize an opportunity quickly. A biome with very little rainfall or plant life. Desert. A desert is a dry area where there is little water and consequently very few plants and animals can survive. Imagine you're trying to cook a meal with just a few ingredients left in your pantry. Just like this culinary challenge, a desert is a natural environment with very limited resources, specifically rainfall and plant life. In both cases, whether you're working with scarce ingredients or scant rainfall, you have to make the most of what's available to survive and thrive, highlighting how ecosystems and chefs alike innovate, and adapt under constraints. A treeless biome with long, cold winters and short, cool summers. Tundra. Tundra is a cold, dry region where the ground is often frozen and only hardy plants like mosses and lichens can grow. Imagine trying to host a barbecue in a parking lot where it's always either too hot or too cold. Just like that challenging setup, the tundra is a vast, treeless biome where the climate conditions are extreme, with long, cold winters and short, cool summers. In both scenarios, whether it's the uncomfortable parking lot or the harsh tundra, the environment is not conducive to certain activities, like growing tall trees or holding an enjoyable barbecue, due to the lack of a stable, moderate temperature. A shrubland with hot, dry summers and cool, wet winters, it is also known as Mediterranean shrubland. Chaparral is an ecosystem characterized by dense, drought-resistant shrubs and is adapted to periodic wildfires. Imagine trying to maintain a balanced diet throughout the year, where you indulge in heavier, richer foods during winter and switch to lighter, hydrating meals in the summer. This cycle of dietary changes is similar to the chaparral's seasonal pattern of experiencing cool, wet winters followed by hot, dry summers. Just as you adapt your meals to suit the climate and the needs of your body in each season, the chaparral ecosystem thrives by adapting to its drastic seasonal shifts, with plants growing lush and green during the rainy winter and conserving water during the arid summer. An area where fresh river water mixes with salty ocean water. Estuary. An estuary is where rivers meet the sea, creating a unique and productive environment for many species. Imagine trying to mix cold and hot water in a bathtub to get the perfect temperature for a comfortable bath. This is similar to how an estuary functions, where fresh river water blends with salty ocean water. Just as you need to balance the hot and cold to create a warm, pleasant bath, an estuary balances the different temperatures and salinity levels of the two water types, creating a unique and diverse environment. An area of land that is periodically underwater. Wetland. Wetlands are natural areas where water covers the soil, creating a unique environment for plants and animals. Imagine trying to maintain a garden in a yard that occasionally floods after heavy rain. Just like the garden, a wetland is an area that is sometimes dry, but periodically submerged underwater. In both cases, the fluctuating water levels create unique conditions. The garden's plants adapt to both dry and wet periods, just as the flora and fauna in a wetland are specially adapted to thrive in an environment that transitions between land and water.